Welcome to the Explainer. Today, we're going to break down one of the most fundamental building blocks of Kubernetes, the pod. We'll get into why it even exists and then see exactly how to create one using a surprisingly simple language called YAML.
Okay, let's dive right in with the question that trips up almost everyone at first. If Kubernetes is all about containers, why doesn't it just, run the containers directly? Why this extra pod thing in the middle? Well, the answer really gets to the core of how Kubernetes thinks about the world. So here's the game plan. First, we're going to tackle the why behind pods. Then, we'll get familiar with YAML, the language we use to talk to Kubernetes. After that, we'll actually build a pod file from the ground up. And finally, we'll bring that pod to life. All right, so to really get why pods are a thing, we first have to bust a pretty common myth. It all comes down to what the smallest piece of the puzzle is in the Kubernetes universe. A lot of folks assume that Kubernetes just takes your container and plops it onto a machine, a node. But that's not quite how it works. And this is the key takeaway. Kubernetes never runs a container by itself. It always wraps it inside an object called a pod. The pod is the thing that actually gets scheduled and runs on a node, not the container directly. I love this analogy. Think of it like this. A node, one of your servers, is like a big apartment building. A pod is a single apartment inside that building. And your containers, they're the people living in that apartment. Kubernetes is a good landlord. It's not going to just leave people wandering the hallways. It makes sure everyone has their own apartment first. And this is where things get really important. When your app suddenly gets popular and you need to handle more users, Kubernetes doesn't try to cram more containers into the pod you already have. Nope, it just creates brand new, identical pods. This is the golden rule, right here. You scale by adding more pods. Now, I know I just said it's usually one container per pod, but there's a really important exception. Sometimes you need a helper container that's super tightly coupled with your main app. Think of something that collects logs or a proxy that sits right next to it. In those cases, you can put them in the same pod. And because they're together, they automatically share the same network and storage, which makes them super easy to work with. So we get what pods are and why we need them. But how do we actually tell Kubernetes, hey, go make me one of these? Well, you don't need to be a programmer. You just need to know how to write a simple configuration file. And that file is written in YAML. Now, the big word here is declarative. What that means is you don't give Kubernetes a list of commands, like a recipe. Instead, you just describe the end result. It's like showing it a picture of the finished cake and saying, make this. You declare, I want one pod, and it should be running the Nginx image. And Kubernetes figures out all the steps to make it happen. It's an incredibly powerful way to manage your infrastructure as code. Now, YAML can look a little intimidating at first, but trust me, it all boils down to just 3 simple rules. Once you get these 3 things down, you can write pretty much any Kubernetes file you'll ever need. First up, key value pairs. Super simple. Think of it like a dictionary. You have a key, like kind, then a colon and a space, and then its value, pod. It's just a way of defining properties. The order doesn't matter for these. The second rule is lists. A list is just, a list of items. And you can always spot a list item because it starts with a little dash and a space. Now, unlike those key value pairs, the order of items in a list is definitely important. And finally, the big one. The one that gets everyone at some point, indentation. YAML uses spaces to show how things are nested together, to show the structure. And it is so strict about this. You have to use spaces, never tabs. Get this wrong, and Kubernetes will just say nope and reject your file. All right, we know the rules of the game now. Let's put it all together and see what a real-world pod definition file actually looks like. The cool thing is, once you learn the structure for a pod, you basically know the structure for everything in Kubernetes. Whether it's a pod or something way more complex, almost every object definition is built from the same 4 top-level sections. Just 4. And here they are. You've got API version, which just tells Kubernetes which version of its API we're using. Then kind, which is what we're trying to create. In our case, a pod. Metadata is data about the object, like its name. And finally, spec. Spec is the most important part. It's the specification, where we describe exactly what we want this thing to look like and do. Okay, let's build one. We start at the top with the first 2 mandatory fields. We're telling Kubernetes we're using its stable v1 API and that the kind of thing we want to make is a pod. Simple enough. Next up, we add the metadata. And see that indentation? That's YAML telling us that name belongs to metadata. we have to give our pod a unique name so we can find it later. Let's just call it Nginx pod. And finally, the real meat and potatoes, the spec. This is where we say what we want inside the pod. We specify a list of containers. See that little dash? We give our container a name, Nginx, and then the image line tells Kubernetes, go to a registry like Docker Hub, find the official Nginx image and run it for me. And that's it. That is a complete, totally functional pod definition. So we've written our YAML file, our blueprint. How do we actually give this to Kubernetes and tell it, okay, time to build? For that, we turn to our trusty command line tool, kubectl.
These 3 commands are going to be your best friends starting out. kubectl create is how you feed it your YAML file. kubectl get pods is how you check to see what's running. And kubectl describe is how you zoom in and get all the juicy details about one specific pod. And I really can't stress this enough. If you remember one command today, make it this one. When something goes wrong, and trust me, it will, when your pod won't start or it's crashing, running kubectl describe on that pod will almost always show you an events section that tells you exactly why. It is your #1 debugging tool, period. So, there you have it. You've mastered the atom, the fundamental building block of Kubernetes. You know what a pod is, why it exists, and how to create one. But a single pod is just the start. The real magic, the real power of Kubernetes comes from the controllers that sit on top of pods, managing them for you, scaling them, healing them, updating them automatically. The question is, how do you go from 1 pod to 1,000? We'll get into that in our next explainer.